Hi, I'm Brian Peters, and I just wanted to show you some of the features of my synth that I'm just calling the Teensy Synth at the moment. When you plug it in, it makes a little hello world sound, and should show up as a MIDI plug-and-play device on your computer. It's also programmed to blink the LED on the Teensy board every time it receives a MIDI note on, continuous controller, or pitch bend message. MIDI channel 1 mode is built off of a few tricks utilizing the Arduino pulse width modulation. In this mode, it's turning the pulse width modulated output on and off at the base frequency you're creating, so when the output would normally be high, it's oscillating at 4 kHz with a width determined by the mod wheel, and when the output would normally be low, it is low. When the pulse width modulation reaches a 100% duty cycle, it then just outputs a square wave. When it reaches 0%, it's silence. All the tonal modes on the synthesizer have portamento legato enabled, so if you play a note without lifting up the previous note, it glides to the new note, instead of stepping to the new note. While holding down notes, it keeps track of the order you play them in, so if I play this C minor triad and lift up the G, it knows that the E flat was the note played before the G. If I play the same triad and lift up the E flat instead, nothing happens. But if I play the triad with the E flat first and then lift up the G, it goes down to the C instead. Using the duty cycling, I also added a decay envelope feature, which is mapped to continuous controller 3. Anytime CC3 is anywhere other than at 0, it deactivates the legato mode, so you don't get unintentional behavior from overlapping notes. CC6 activates a neat feature, which is that it causes the pulse width modulation carrier frequency to mirror the oscillating frequency but up 1 octave, which gives some organ-type sounds. MIDI channel 2 features a square wave as the basic sound, but also has a polypulse, which you can turn on with CC6. This is sort of like that pitfall sound on the Atari TIA. Channel 2 also features vibrato, which is assigned to the mod wheel. All the synthesizer modes also respond to the pitch bend wheel. Continuous controller 2 allows you to set the bend range between 1 and 12 semitones. Here it is set at 12 semitones. And here it is at 1 semitone. MIDI channel 3 is set up as a 25% duty cycle pulse wave. This is sort of like the duty cycle mode on Nintendo's 2A03 chip. Channel 3 has a decay feature like channel 1, but instead of changing the pulse width modulation duty cycle, it changes the actual duty cycle of the base frequency waveform. So you can go between 25% and 0%, or all the way from 100% to 0%. MIDI channel 4 is identical to channel 3, except that it defaults to 12.5% duty cycle. One feature on all the channels is an arpeggiator, which is mapped to CC4. The arpeggiator speed is mapped to CC5. MIDI channels 5 and 6 aren't usable concurrently. They both use the Teensy 3.1 12-bit analog output, although I'm only using 8-bit resolution for the output. This is the output that doesn't have a header pin and is in one column on the bottom of the Teensy. On channel 5, it plays some 8-bit drum sounds that are embedded in the code itself. The mod wheel and the pitch bend wheel both control the sample playback rate. And I also put some of the sample addresses outside of the sample area in the memory, so it just plays back the program itself in the flash memory. MIDI channel 6 is an 8-bit waveform oscillator. It has the same CC controls as channel 2, but CC6 selects between one of 12 different waveforms that I've programmed in. The first 4 are different duty cycle pulses, which you can use to toggle between quickly to get some Nintendo 2A03 shimmering sort of sounds. Waveform 5 is a 2-bit triangle with a hiccup at the end to sound like a Game Boy. Waveform 6 is a 2-bit saw. Waveform 7 is a 3-bit triangle. Waveform 8 is a 1-bit Atari polypulse. Waveform 9 is another 1-bit polypulse. Waveform 10 is another 1-bit polypulse but with some extra harmonics. Waveform 11 is a 2-bit polynomial. And waveform 12 is an 8-bit polynomial. And all of those respond to the pitch bend, vibrato, and arpeggiator functions as well. So, thank you for watching this video. I hope this can help you decide if this is a synthesizer that you want to try building yourself. And if it is, you can find everything you need in the Arduino projects section of my website at www.brianpeters.net. You can also find videos there and in the description of this video of these synthesizers being used to make actual music, which is a lot more entertaining.